Okay, so we're going to review and learn, review the formulas for a rectangle, a parallelogram, and a triangle. So area of a rectangle is base times height. You might have also learned it in elementary school or even middle school as also length times width. Either way, but our problems, we're going to be looking for the right angle to indicate the height of the rectangle. The formula is the same for the parallelogram. Now, sometimes they will try to trick you on standardized tests, and they might give you a parallelogram that looks like this, and they might have a bunch of numbers here. Now, the height is always indicated by a right angle. So let's say this was 6, 4, and 8. The only numbers we would use to find the area of this parallelogram would be 4 times 8, and that would be 32. This 6 is the slant height, and we will not be using that to calculate an area. It's always going to be, the height will always be by a right angle. The formula for area of a triangle, 1/2 base times height. You might have also memorized it as base times height, divide by 2. Either way, you can calculate the area of the triangle either multiplying it by 1/2 and then the BH, or multiplying the B and the H and divide by 2.
So we'll never use the length of the slanted side?
Not to find an area. You're going to probably need to turn it into a right triangle, and then you'll find a missing piece. And that's what we're going to do in the examples. All right, formula for area of a rhombus. That is diagonal 1 times diagonal 2, and then multiplied by 1/2 or divided by 2. So this may be a new formula. You may not have seen area of a rhombus, but we will be doing those. Okay, let's do the area of this parallelogram. Notice they've only given me, if you remember, the formula is base times height. The only thing I have is the length of this base, which is going to be 12. I need to find the height. So what I'm going to do to find the height is I've got a special right triangle sitting here on the side or on the edge of my parallelogram. So let me go ahead and pull this off. $60 is down here, so that tells me 30's up here. Remember that the side across from 30 is x. The side across from the 90 is 2x. And what I'm looking for, this height, is going to be whatever x is with square root 3. So notice in my figure, x is equal to 2. So the height of my parallelogram is 2 square root 3. So to find the area of this parallelogram, my base is 12, my height is 2 square root 3, so the area of this parallelogram is 24 square root 3 units squared. This time they didn't show us where the triangle is formed. This 45 is for this angle right here. So if I drop down my height, I could slice off this 45 degree right triangle. Again, you're going to memorize that the two legs are going to be the same, and the hypotenuse is x square root 2. And that's what I have. I have this, which equals 6. So to find the height, I'm going to solve that equation. So x square root 2 equals 6. Divide by the square root of 2. X is equal to 6 over square root 2. Rationalize. 6 square root 2 over 2 simplifies to 3 square root 2. So that is x, which is both this side here and this piece here. But I don't need to worry about the bottom. I was only looking for the height. Remember, opposite sides in a parallelogram are congruent. So the base here, if you want to think of a parallelogram sitting on its base, it's 9. So area equals base times height. So 9 times 3 square root 2. So the answer for the area of this parallelogram is 27 square root 2 units squared. So for the triangle, notice I have my base and height. So this is the base, this is the height. So all I need to do is 1/2 BH. So 1/2 46 times 12. I can take half of 46 and make it 23. And then 23 times 12 gives me 276. And these are millimeters squared. If you'd rather take half of 12, you can do that. Doesn't matter. Or you could do 46 times 12 and then divide it by 2. Slide. Now, for this slide, it's showing you 3 different ways to find the area of a rhombus. Now, on the previous slide, we learned the formula that it was 1/2 diagonal 1 times diagonal 2. And that's what they want us to do in part B. So let me do that one first. Now, notice in my description here, it's telling me that the length of AC is 20. So this entire diagonal is 20. And then the other diagonal, the BD, that one's 15. So if I go ahead and just plug it right in here to the formula, I'm just doing 20 times 15 and dividing it by 2. 20 times 15 is 300, or you could even take half of 20 and make it a 10, and the answer is 150. Now, the other 2 techniques that you can do to find the area of your rhombus, notice they're giving us this height out here. So we could treat this as a parallelogram, and what we could do is BH, the H is 12, and this 12.5 is congruent because it's got a tick mark. So for the first one, all I'm going to multiply here is 12 times 12.5, and they already put the 12 there. And then once I multiply that, I also get 150. The other way to solve this is to realize you have 4 congruent right triangles here. Because if you recall back from our parallelogram chapter, or our quadrilateral chapter, the diagonals of a rhombus are perpendicular. So I have 4 little right triangles here, and they're all congruent. So this is why I'm going to multiply it by 4, and then for this part, it's going to be 1/2 base times height. Once I find the area of one of the triangles, I can just multiply it by 4. Now, remember these diagonals have been bisected, so if the length of the whole thing was 20, then this little triangle, this little piece is 10, and this little piece is 10, and then I could split my 15 into 2 and make this 7.5, 7.5. So now I'm going to do 10 times 7.5, divide by 2, and then times by 4, and I still get 150. So if I do this and multiply these 2, I get 75, and then times by the half. Half of 75 is 37.5, times that by 4, and I get 150. So either way, I still get the same answer. Okay, so your homework for this set of notes is that worksheet. When you click on the assignment, make sure you read which problems to do. I think it tells you to skip 2 of them because there is a picture of a trapezoid in there, and we did not cover the area of a trapezoid, but you probably learned it in middle school. But just to read it in case you ever see it on a standardized test, a trapezoid looks like this. We talked about it when we did the quadrilaterals. Again, we need a height. So it would be a base 1 and a base 2. This would be a height. So the area of a trapezoid is 1/2 height, and then base 1 plus base 2. So the instructions tell you to skip this question. However, be aware of this formula because you should have learned it in middle school. And that is it for the extra areas.